still got its H on it. Iron dichloride now at this point. Mono, dichloride, whatever. Okay. Yeah. I'm just going to leave it generic. Some base, we'll grab that. Could be the solvent, could be the chloride that got kicked off. Okay. And that is going to give you that adduct. Okay. Well, we've got two more leaving groups on the iron, so it can happen two more times. Okay. So that now you have three of these guys on iron. Okay. This can still behave like a Lewis acid, still be attracted to phenol groups. Oops. Excessive repulsive. Sorry. It doesn't do a substitution, it just adds on. Okay. Wrong sign on that thing. Sorry. Negative. Base. Oh, and this has a negative 1 charge now. So base is going to grab that proton. Sorry. Get a little crowded here. All right. Bird, come on. You can do it, dude. Just do it that way. Okay. This is still a Lewis acid, surprisingly. So this process happens 2 more times. 2 times more. That's what gives us that. All right, positive tests, all kinds of different. Blue, purple, green. It's usually fairly dramatic. Okay. That's your positive indicator. Okay. False positives. False positives aren't other alcohols, okay? Right? Phenol is really just a subcategory of alcohol. But it's really specific to phenols. But there is one thing that looks like a little bit like an alcohol. It can behave as a false positive. That is carbonyls that enolyze easily. I think, yeah, I can't remember, in a couple of the sections during your literature presentations, I talked about this. I don't remember if it was this section. But let's say you have, this is a carbonyl that can enolyze tends to happen when you have actually two carbonyls, one carbon away. Okay? All ketones, even some ketoesters, aldo ketones can do what's known as enolines. Okay? It's a rearrangement. Okay? So it's also called a tautomerization. Okay? So all ketones can do this. All right? Most ketones prefer to be in the ketone state. However, when you got this dicarbonyl thing, they tend to actually prefer this enol form. Okay? It's just a rearrangement. Okay? Can we talk about this in the reports? All right, and what was the reason? Why does this prefer the enol version, whereas most ketones prefer the ketone version? There's a few. What's that? Resonance, yeah. There's a few answers in organic chemistry, a handful of them that if you just keep in your pocket. Sterics, resonance, electronics. A lot of the time it's one of those. In this case, it is actually resonance, right? This alkene can now resonate. If you have an enol, so I should actually define an enol. An enol is an alkene with an OH directly attached to one of the alkene carbons. Okay? And so you can sort of see the similarity between an enol and a phenol. Okay? Maybe it makes a little bit of sense that they can serve a small problem. Sound good? All right. Next test I want to talk about is the acid chloride test. And this is for alcohol, amines, or phenols. And so if you suspect you have any of those groups, you should do an acid chloride test. I have a separate handout for the acid chlorides test. It's an involved test. And you have to do the reaction one week and then do the analysis the next week. That's why I'm introducing it a little bit, early. We don't want to introduce this in the last week. You do have to sort of do the reaction today and then you analyze it next time.
Do we only have one more week after this?
We have 3 more weeks.
What's the last word?
Phenols.
Oh.
Phenols. Yeah.
This is the same thing as the acetyl thing? Word?
Acetyl chloride. Yeah. Yeah, actually, that's what I should say. Acetyl chloride.
So if we get a positive on the ferric chlorides, do we bother with this
Yep.
one?
Yep, absolutely. Amines as well. Alcohols, so if you're in that neutral category, it could be a ketone, an ester, or an alcohol, or an aldehyde, okay? If you get a positive DMP test, don't do this test, okay? You know it's a ketone or an aldehyde. DMP is pretty reliable. If you are convinced you have a neutral compound, and you get a negative DMP test, you should do this, okay? To see if it's an alcohol. All right, how is this going to work? I'm going to show you with an alcohol, but it would be essentially the same mechanism with a phenol or an amine. And by the way, you'll only get a positive test. I haven't talked about this yet. Put a star right there. I'll come back to that. There's one type of amine that won't give you a positive test on this. Okay. Triethylamine. Okay, it's typically done. We do ours in ether as the solvent. And what you're doing is, let's say your unknown is an alcohol, you're converting your unknown into an ester. That doesn't mean that now you say, oh, my unknown's an ester. Well, you converted it into an ester. That means that the fact that you have an ester at the end serves as confirmation that you have an alcohol for your unknown. Byproduct. ET is ethyl, right? You guys know that? Okay. So how does this guy work? Well, acid chlorides have a very strong partial positive charge right there on that carbon. These lone pairs are attracted to that. So they attack that carbon, and the electrons pick up there. We create what we saw last week. We create a tetrahedral intermediate. Okay. Tetrahedral intermediates can fall apart and kick something off. Here it's going to kick off the chloride. We already know chloride's a happy anion, right? I flipped that guy around a little bit, but hopefully you'll be able to follow. Okay, and then triethylamine. Deprotonates. Get this guy. Alright. And there are some key spectral features to look for. Okay. First of all, you've created a carbonyl. We tend to, the handout describes key features in terms of NMR, proton, and C13. It also describes it in terms of IR. Most students tend to pay more attention to the NMR for this one. Okay? You will create an ester carbonyl in your C13. Okay, when you run it of your product of the acetyl chloride test. All right. Your original unknown. So if your original unknown had no carbonyl peak, but now it has a carbonyl peak around the ester area, 140 to 160, something like that. That would be a sign. This brand new methyl group that'll show up somewhere around 2. Okay. So you got a new singlet, right? Because it's got no neighbors, so you get a new singlet somewhere around 2. It's another sign. Oh, okay, this is a positive test. Must have been an alcohol. Okay. If you do this because you suspect you have an amine, the amine product will look like the amine goes from amine to an amide. Have you guys learned yet in Dr. Morgan's class the difference between a primary amine, a secondary amine, tertiary amine? You guys learned that? It's different from alcohols. Okay? If you have to decide, What type of substitution is this alcohol? Okay. What type of substitution is that? Is that a primary alcohol, secondary alcohol, tertiary alcohol? Secondary. You decide by looking at the carbon that the OH is attached to and going off that. That's a secondary carbon, so that is a secondary alcohol. Amines are different. Amines depend on how many alkyl groups you have. Okay? Any neutral amine is going to have 3 different groups on it. Okay? A mixture of hydrogens and alkyl groups. If it's 1 alkyl group, it's a primary amine. It's 2, it's secondary. It's 3, it's tertiary. Okay? You got it? Depends how many of those R's are alkyl groups. Okay? Let me test you. Alright. Is that a primary amine, a secondary amine, or a tertiary? How many alkyl groups are attached to the nitrogen? We always said that every nitrogen of an amine has 3 things. It's 1. That's a primary amine. Right? It's got 1 alkyl group and 2 hydrogens. You were going off the carbon again. You don't go off the carbon. You go, how many alkyl groups does that nitrogen have? Does that make sense, the difference on how you do it? This reaction will only give you a positive test for primary and secondary amines. It won't give you a positive test for tertiary amines. So just because you get a negative test, you think you have an amine, you get a negative test. That negative test could mean one of 2 things. You don't have an amine, or you have a tertiary amine. Does that make sense? The secondary primary stuff is that's reiterated in the handout for the acetyl chloride. Okay? Oh. All right, one last test.
How do we confirm positive platinum? We just use spectrum work?
Yeah, spectroscopy. Again, you know, the new carbonyl in the C13, similar shift to ester carbonyl. Okay? You have a new methyl group on the proton NMR. Okay? And again, all that stuff, the things that you're looking for on the NMR and stuff like that, that's very explicitly highlighted here. Okay. The next is the Lucas test. A little bit limited in its utility. It's a test for alcohols, right? Okay. But it only works with water-soluble alcohols. Okay, so it has to be, oh, I'm in the neutral category. I got a negative DMP test. Okay, so I suspect it's an alcohol. So I'll run the Lucas test. It's easy to run, so. All right, I don't like how my notes are lined up, so I'm going to add this. It's always a bad idea. All right. Okay. Basically, I want to draw a generic form of the alcohol that could be primary, secondary, or tertiary. Okay? Here, it is, for the alcohol, it is based on the carbon. If two of these things are alkyl group, it's secondary alcohol. If only one of these R's is an alkyl group and the other two are hydrogens, it's primary alcohol. So what happens? You treat it with zinc chloride. Put HCl in there and water. And you get plus HCl. Okay. All right. You get different things depending on your alcohol type. Okay. If it's a tertiary alcohol, all right, it becomes cloudy. Okay. It's in water, and it's we already decided we're doing this just because it's soluble in water, so it's clear, right? It's a clear solution. You run the test, and it becomes cloudy. That's the qualitative difference you're looking for. That's the indication of a positive test, is it becomes cloudy. Okay? Now, when does it become cloudy? If it's tertiary, it becomes cloudy. It tends to become cloudy immediately. Okay. If it's secondary, it tends to become cloudy after 3 to 10 minutes. Okay. And a primary tends to give you no reaction. I mean, maybe, you know, I can't remember if I have students who claim, no, after a half hour, it gave me a positive test. Okay, but it ain't 3 to 10 minutes. All right, let's look at the mechanism and let's see if we can decide why we get this difference. Zinc chlorides. Okay. Kind of like what we saw with ferric chloride. We can attack the zinc, so Lewis acid, kick off the chloride. This guy can fall apart a little bit differently than what happened. You couldn't do this with phenol. Okay? This can actually become a leaving group and make the, kind of like we've seen, you know, protonating an alcohol so it becomes a leaving group. We saw that in the cyclohexenes lab the first semester. Here, we've used a Lewis acid, which activates this OH to become a leaving group. So this guy can leave. Okay? I'm sure it was plus chloride, right? We kicked off that chloride. He's still floating around. This stuff leaves. Okay? This chloride can attack, attach, and boom. Okay? And we get cloud. Now, Why do we get this difference for tertiary, secondary, and primary alcohols? You very much know this answer.
Resonant.
What's that?
Resonant.
Steric, electronics. Not those. This goes in the pocket next to those. A little bit less used, but still important. What type of reaction is this? You've seen this reaction. You've done this reaction. Ultimately, what did we do?
Substitution.
It's a substitution. What class? What category of substitution? Of our classic reactions we've learned. Electrophilic aromatic substitution. Now there ain't no aromatics. What's the two main classes of substitution reactions we learned? Yeah, which one's this? SN1. How do you know that?
I was taking a shot in the dark. Oh, yeah, sure.
Don't play it off.
Okay.
Especially when you get the right answer.
I'm
Fake it
honest.
till you make it.
Okay. I was taking it till I make it, but I was being honest about it.
That's not faking it. Carbocation. If you get a carbocation, you know it's one of the it's one of the one reactions. SN1 could be an E1, okay? Because you got a carbocation. I'll ask again. Why do you get that difference? What do we know about carbocations?
It's my favorite.
You double noted, Gail?
It's the
Okay, your thumb was. My son's double noted. It's his proudest achievement in life. What's that?
This one is more stable than,
Which one?
or sorry, the tertiary one.
Tertiary.
It'll be more stable than the
That's
one.
the whole difference in stability of carbocations, right? So if there's the more alkyl groups, the more stable the carbocation. You can't even really make primary. That's why essentially no reaction. Okay. This could probably happen over time through an SN2 reaction, actually. Not do it this way, do it a different way. But yeah. Make sense?
Sure.
Questions?
So if we have primary and we get a negative on this glucose test.
But you get a positive acetyl test. Not only have you confirmed that your suspicion about an alcohol, but you even sort of got some information about what type.
Okay.
You know, and that type of information could be confirmed by spectroscopy, by NMR and C13 and stuff. So there's almost always, you know, more than one bit of information that's going to give you the answer you need.
The spectra we need to take for the acetyl chloride test, is that on the more in-depth instructions?
But yeah. I mean, it's essentially just taking an NMR and a C13 again. All right. Who has one of your unknowns? It's not soluble in chloroform. One of your unknowns? Is that it? Somebody else? Okay, I've got some bad news. You have to do your NMR last. It's not good to, remember last week I said only chloroform ones? Oh shoot, we didn't finish, not everybody, did you do one? Did you do the other one? Okay. Who did not? You three? Okay. We'll start here. Okay, we'll do you three. And then we'll do you guys on number 2. Okay? And then we'll do you on number 2. And we'll do it in deuterated methanol. The one that's not soluble in chloroform, deuterated methanol. Okay? So it's back there.
Boiling point and the
Boiling point, nitrous acid, I forget what we call it, where we figure out the molecular weight with titration. Those 3 I will discuss next time.
And then the mass,
Mass specs we'll start to do probably next week.
okay, cool, thanks.
Yeah.
I couldn't find the transfer of it, so.
Okay. All right, I'll make it. Do you
Sorry.